Now, I'm going to start today's lecture. You have learned about condition for geometrical isomerism. There are two conditions for a molecule to show geometrical isomerism. First is molecule must have restriction in rotation. Molecule must have restriction in rotation. And second is restricted atoms must have different substituent. Here A, here B, here A, here B. It may be possible that all the four atom groups are different. Is it clear? Is it clear to everyone? Tell me. Is it clear to everyone?
Yes, sir.
Yeah.
Yes, sir.
Now you have already learned about this part along with general cases of geometrical isomerism. What are the general cases where geometrical isomerism are seen? First is, tell me, anyone, what are the general cases?
Carbon-carbon double bond.
Very good. First is along carbon-carbon double bond. Here A, here B, here A, here B. It may be possible all the four valencies are different. Here A, B, here A, B, or C, or D. Very good. Along carbon double bond, carbon. Second is along.
Carbon double bond nitrogen.
Very good. Carbon double bond nitrogen. Here A, here B, here already lone pair and bond pair are different. The second is along carbon double bond nitrogen. Third is along
nitrogen double bond nitrogen.
good. Nitrogen double bond nitrogen. Here lone pair bond pair already different. Lone pair bond pair already different. Very good. And fourth one is along
Cycloalkane.
very good.
Alkanes.
Along cycloalkanes. Here A, this is B. A have different substituent A, B, and this particular B also have different substituent A and B. It may be possible that all four are different. Last, fifth one. What is that?
Along cycloalkenes.
Alkanes.
Very good. Along cycloalkenes. But it is also important. The number of atom in the ring must be greater than or equal to 8. So these are the 5 cases from which questions may be asked. But at the competitive environment, competitive level, if you will go through the questions, you will only see along carbon-carbon double bond in open chain as well as cyclic system. But for forming good questions, the concept of this and this are mixed. Is it clear to everyone? If you will go to the questions which are asked in competitive examination, IT or medical both, you will only see along carbon double bond carbon, maybe of open chain, maybe of ring. But to get better understanding, you must know all the 5 parts. Along carbon double bond carbon, along carbon double bond nitrogen, along nitrogen double bond nitrogen, along cycloalkane, and along cycloalkenes. Is it clear? Is it clear?
Yes, sir.
Yeah, you have done many questions.
Yes, sir.
You have done many questions to find molecule which show geometrical isomerism. Now we are going to learn how this carbon double bond nitrogen, will be formed. Okay, write the heading: formation of carbon double bond nitrogen. Write the heading: formation of carbon double bond nitrogen. Write it down. Right? Formation of carbon double bond nitrogen. Now, first understand the concept behind that. When aldehyde or ketone, aldehydes are those compounds in which here C double bond O is connected with H. Here may be H, here may be carbon. So this is aldehyde. When aldehyde or ketone, here you can also take R, CCOC, it will be ketone, and RCOH, it will be aldehyde. You can take aldehyde or ketone. Here, aldehyde or ketones. First think for the concept, then you will write this. When aldehyde or ketone reacts with NH2G, when aldehyde or ketone reacts with NH2G, this G may be H. This G may be H, here H. This G may be H. This G may be any alkyl group. This Z may be hydroxide group. This Z may be NH2 group. This Z may be replacement of this hydrogen with phenyl group, that is 2,4-dinitrophenylhydrazine. This Z may be NHCO NH2. This is called as semicarbazine. So when aldehyde and ketone reacts with NH2G, then a water molecule will be removed. This water molecule is removed, and a compound with carbon double bond nitrogen will be formed. When this water goes out, then there is formation of carbon double bond nitrogen. Here H, R, here H or R. These two R may be same, these two R may be different. Think once again. When aldehyde and ketone, when reacts with NH2Z, it eliminates a water molecule. And after elimination of this water molecule, a carbon double bond nitrogen bonded compound will be formed. If this is H, then such compound is called as ammonia. That means when aldehyde reacts with ammonia, it may be ketone also. When aldehyde or ketone, it may be R, then in that case it will be ketone. So when aldehyde or ketone reacts with ammonia, then a compound will be formed which is called as imine. Is it clear? Imine. Carbon double bond nitrogen system connected with H, it is called as imine. When aldehyde or ketone reacts with primary amine, RNH2, this is called as primary amine. So when aldehyde or ketone reacts with primary amine, a water molecule will release and there is formation of carbon double bond nitrogen, and such compound is called as alkyl imine. This is also called as Sif base. In IEEE time, this question was asked, which molecule is called as Sif base? You must know carbon double bond nitrogen, and when nitrogen is connected with R, then such compound is called as Sif base. Is it clear? Is it clear?
Yes, sir.
Yeah.
Yes, sir.
So when aldehyde or ketone react with NH2OH, this NH2OH is called as hydroxylamine. So when aldehyde or ketone reacts with hydroxylamine, a water molecule goes out and there is formation of carbon double bond nitrogen, in which nitrogen is connected with OH, and such compound is called as oxime. This is NH2NH2, which is called as hydrazine. So when aldehyde or ketone reacts with hydrazine, a water molecule goes out and there is formation of carbon double bond nitrogen, and nitrogen is connected with NH2. This is called as hydrazone. Similarly, if derivative of hydrazine, that is 2, this is 1, this is 2, this is 3, this is 4. When 2,4-dinitrophenylhydrazine is react with aldehyde or ketone, then also water molecule goes out and there is formation of carbon double bond nitrogen. Similarly, this NH2, NH2, this is called as semicarbazine. When this semicarbazine reacts with aldehyde or ketone, then also a water molecule goes out and there is formation of carbon double bond nitrogen. So these are some terms. These are some terms which are commonly used in organic chemistry. These are mainly terms when you will study in aldehyde ketone chapters, then in that case it will be encountered. But here you are reading about geometrical isomerism, so it is also important you must know these terms: imines, alkyl imines, oxime, hydrazone, and hydrazone derivative. Is it clear?
Yes, sir.
Sir.
Can you remember these all names today itself?
Yes, sir.
Yes, sir.
Very good. Now write some terms, then only you will understand better. Right, in definition part. When aldehyde or ketone, write in the notebook so that your notes will be completed and you can revise properly. Right. When aldehyde or ketone, when aldehyde or ketone reacts with NH2G, G may be H, G may be R, G may be OH, G may be NH2, G may be derivative of NH2. So when aldehyde or ketone reacts with NH2G, then carbon double bond nitrogen, bonded compound will be formed. Now, after writing this, you should write this one. When aldehyde or ketone react with NH2C, a water molecule goes out and there is formation of carbon double bond nitrogen. So after writing this, you have to write this one. And after completion of this one, you also write this part. Here, alkyl group may also be there. Write it down. When aldehyde or ketone reacts with ammonia, it will give imine. Carbon double bond nitrogen compound is called as imine. Carbon triple bond nitrogen compound is called as nitrile. And carbon single bond nitrogen compound is called as amine. You must be clear what is amine, what is imine, and what is nitrile. Carbon single bond nitrogen, it is called as amine. Carbon double bond nitrogen, it is called as imine. And carbon triple bond nitrogen called as nitrile or cyanide. Have you noted that? Write something in comment box too, so that I can read and find whether you are listening or not. Have you noted? Yes, sir. Good, Abel. Once again, try to learn this name. Try to get some concept behind this. When aldehyde or ketone reacts with NH2G, a water molecule is removed. And there is formation of carbon double bond nitrogen. Carbon double bond nitrogen will be obtained. When the Z is H, that is NH3. When the Z is H, that means when aldehyde or ketone reacts with ammonia. Then a compound with carbon double bond nitrogen will be formed, and this compound is called as imine. When aldehyde or ketone reacts with RNH2, that means primary amine, a water molecule goes out and there is formation of alkyl imine, which is also called as Sif base. When this aldehyde or ketone reacts with hydroxyl amine, which is NH2OH, in that case, oxime will be formed. When aldehyde or ketone reacts with hydrazine, then hydrazone will be formed. And if one hydrogen of this hydrazine is replaced with phenyl, and phenyl hydrogen is replaced with nitro with position 2 and 4, then such compound is called as 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine. So when 2,4-dinitrophenylhydrazine reacts with aldehyde ketone, then carbon double bond nitrogen system will be formed. Okay, and when this semi-carbazine reacts with aldehyde ketone, then there is formation of carbon double bond nitrogen, and this compound is called as semi-carbazine. zone. Is it clear to everyone? Tell me. Is it clear to
Yes, sir.
everyone?
Yes, sir.
Very good. This 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine. This is also called as 2,4-DNP. This is also called as 2,4-DNP, which is a chemical test, of aldehyde or ketones. You must remember, 2,4-DNP is a chemical test. 2,4-DNP is a chemical test of aldehyde or ketones. If any molecule have aldehyde or ketone, this can be tested. This can be tested by this particular 2,4-DNP. Is it clear? Is it clear to everyone?
Yes, sir.
Sir.
Now, important thing. Try to understand. Question in geometrical isomerism. What type of question will be coming from this part thing? If this aldehyde or ketone is symmetrical, that means this is H, this is H. So aldehyde is formaldehyde. So only one aldehyde which is symmetrical, which is called as formaldehyde. Other than this formaldehyde, if you use any carbon, maybe methyl, ethyl, propyl, maybe aliphatic, maybe aromatic, you can connect benzene also. So when H is replaced with any carbon containing group, then such aldehyde are called as unsymmetrical. Like this. Maybe R, maybe AR. This is unsymmetrical. So when symmetrical aldehyde reacts with NH2Z, when symmetrical aldehyde reacts with NH2Z, a water molecule goes out and form a compound like this. Where here H and H are present. Similarly, when unsymmetrical aldehyde reacts with NH2Z, it will also loses a water molecule, but here the compound formed will be like this. Now, think for the differences. In this case, this end have both hydrogen same, but at this end here hydrogen and alkyl group, phenyl group or any different groups are present. So in first case this end have same substituent. Here this nitrogen have different substituent. But in second case this carbon also have different substituent and this nitrogen also have different substituent. That means when symmetrical aldehyde reacts with NH2Z, when symmetrical aldehyde reacts with NH2Z, it form a compound that will not show geometrical isomerism. Once again, when symmetrical aldehyde reacts with NH2Z, it will form a compound that will not show geometrical isomerism. But when unsymmetrical aldehyde reacts with NH2Z, it will form a compound that will show GI. Is it clear? Is it clear? Now, question is asked from this segment only. Write it down. Write it in your notebook so that you can solve. You can revise in the future classes, future times. Write it down. When symmetrical aldehyde, right? When symmetrical aldehyde, here I'm writing here, when symmetrical aldehyde reacts with NH2G, then it will form a compound that will not show GI. That will not show GI. GI means geometrical isomerism. But unsymmetrical aldehyde reacts with NH2Z and form a compound that will show GI. That will show GI. Is it clear to everyone? Is it clear to everyone?
Yes, sir.
Yes, sir.
Now, similarly, think for ketones. If this is, similarly, think for ketone. If this is R, if this is R, alkyl group. This is also R, alkyl group. If both are same. In that case, here again R will be obtained. And if this is alkyl group but are different, this is R dash. Think like this. This is R and this is R dash. If this is different, then in this case R and here R dash will be formed. So again, when symmetrical ketone reacts with NH2Z, it will form a compound that will not show GI. And when unsymmetrical ketone reacts with NH2Z, it will form compound that will show GI. Is it clear? Is it clear?
Yes, sir.
Now, write
sir.
this also in your notebook, because question will be formed from this part. Write this. When symmetrical ketone reacts with NH2G, when symmetrical ketone reacts with NH2G, then it will form a compound that will not show GI. Then it will form a compound that will not show GI. But unsymmetrical ketone, in place of aldehyde, you can use ketone. But unsymmetrical ketone reacts with NH2Z and form the compound that will show GI. That will show GI. Is it clear?
Yes, sir.
Now,
Yes, sir.
now think for the question. Which type of question will be arises from this? When symmetrical aldehyde or ketone reacts with NH2Z, it will form a compound that will not show GI. It means only one product will be formed. Is it clear? When symmetrical aldehyde or ketone reacts with NH2Z, it will form a compound that will not show GI, simply mean it will exist only in one form. But when unsymmetrical aldehyde or ketone reacts with NH2Z, it will form a compound that will show GI, simply means it will exist in more than one form. That will be in normally two forms. Like you can think for this. You can think like this. You can think like this. Now think like this. Here, when I am taking CH3, here CH3, here H, this is O, and here NH2, and here OH. When this water molecule goes out, it will form a compound like this. Here CH3, here H, this nitrogen is connected with OH. This particular carbon has CH3H, this particular nitrogen has lone pair bond pair. That means this will show GI. And if it will show GI, then existence of this molecule will be in two forms. One form, this OH and this H will be in the same side. In one form, this H and OH will be in same side, while in another form, this H and this OH are on opposite side. Is it clear? If this molecule will show geometrical isomerism, this means this will exist in two forms. One will be like this and another will be like this. Is it clear? Is it clear?
Yes, sir.
But think,
Yes, sir.
if this CH3 is replaced with H. If this CH3 is replaced with H, in that case, here again H, then here again H, here again H. In that case, both molecules are same. Is it clear? If
Yes,
this is
sir.
H, this is
Yes,
H,
sir.
this is H, this is H, then both are same. That's why it is said that symmetrical aldehyde or symmetrical ketone will form only one compound, while unsymmetrical aldehyde or unsymmetrical ketone will form two compounds. Now think a definition. Think a definition. Whether these two molecules, think for this particular two molecules, whether these two molecules are mirror image or not. Think whether these two molecules are mirror image or not. What you will say? What you will say? Whether these are mirror image or not. What you will say? Here HOH, here CH3OH. Whether they are mirror image. Tell me whether they are mirror image. No, they are not the mirror image.
No.
They are not the mirror image. Here OH, H are in same side. Here HOH are in opposite side. So they will never be mirror image. They will never be mirror image. Now a term arises. These two are stereoisomers. These two are stereoisomers. They have difference in orientation of atom or group in space. Here H and OH are on the same side. Here H and OH are on the opposite side of restricted bonds. Now think, these two are stereoisomers. These two are stereoisomers and are not mirror image. So a term arises. Two stereoisomers which are not mirror image of one another. Two stereoisomers which are not mirror image of one another are called as diastereomers. Diastereomers. Is it clear to everyone? Definition is clear to everyone?
Yes,
Once
sir.
again listen.
Yes, sir.
Once again listen. If two stereoisomers which are non-mirror image of one another, then such stereoisomers are called as diastereomers. The diastereomers is the relationship between two stereoisomers. Diastereomers is simply the relationship between two compounds. The two compounds have same IUPAC name. Two compounds have same IUPAC name. That means they are the stereoisomers. The two stereoisomers which are non-mirror image of one another, then such compounds are called as diastereomers. So question may also be arises like this. Which compound will react with NH2C to give more than one product? That is two product. Question may also be arises like this. Which aldehyde or ketone reacts with NH2Z to give two diastereomeric product? That means this term may be used. These terms may not be used. Is it clear? Is it clear?
Yes, sir.
Now write the definition also so that your understanding will be enhanced. Right. Write the definition. Write the heading diastereomers. Write the heading diastereomers. Diastereomers. Now write it down. Two stereoisomers. Two stereoisomers. Two stereoisomers which are non-mirror image. Two stereoisomers which are non-mirror image of one another. Two stereoisomers which are non-mirror image of one another are called as diastereomers. Diastereomers. And geometrical isomers will never be mirror image. Geometrical isomers will never be mirror image. So all geometrical isomers are diastereomers. You should also write this. As geometrical isomers are never be mirror image. Geometrical isomers are never be mirror image. So they are always be diastereomers. They will always be diastereomers. Is it clear? Is it clear to everyone?
Yes, sir.
Now write this also.
Yes, sir.
Write this one also. CH3HO when react with NH2OH, then carbon double bond nitrogen will be formed and it will exist in these two forms. These two forms. Have you noted that? Hari.
Yes, sir.
Good. Now think which type of question will be arises. Question may be asked in statement form like this. Which compound reacts with NH2Z will produce a compound that will show GI? Question will be arises in the language form like this. Which molecule reacts with NH2Z to produce a compound that will form GI? If it will take some name like this. When aldehyde or ketone, which aldehyde or ketone reacts with hydroxylamine to form the oxime that will show GI? Is it clear? Think one again. Which aldehyde or ketone reacts with NH2OH, that means hydroxylamine, to produce a compound, to produce an oxime that will show GI? It means if this particular group and this particular groups are different, in that case, the compound that will show GI. Is it clear? If these two parts are different, in that case only the compound which are formed will show GI because they are unsymmetrical. Here, this lone pair bond pair will always be different. Here, if this part and this part are different, in that case only carbon double bond nitrogen system will show GI. So, when unsymmetrical aldehyde or ketone react with NH2Z, then that case the compound will be formed and it will show GI. Is it clear to everyone?
Yes,
Is it?
sir.
Yes, sir.
Now, if I will ask a question like this, whether formaldehyde reacts with hydroxylamine, then the oxime formed will be showing GI or not? What will you answer? Tell me. Whether when formaldehyde react with hydroxylamine and it will form a oxime, whether that oxime will show GI or not? What you will say?
No, sir.
No.
Sir.
No. Very
sir.
good. Very good. Because this H and this H are same. And when this H and this H are same, in that case, the oxime formed will not show GI. But if I will take this CH3COH, like this, CH3COH, and if I will take this unsymmetrical CH3 here H, and when I will ask a question like this, when this acetaldehyde reacts with hydroxylamine, then the oxime formed will show GI or not? What will your answer?
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
No.
Yes,
Yes, sir.
yes, because the CH3H are
Yes, sir.
different. So here HOH are on the same side or HOH are on the opposite side. Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now, in case of ketone, if I will ask question like this is CH3COCH3. It is called as acetone. It is called as acetone. So when I ask a question like this, when this acetone reacts with hydroxylamine, then the oxime formed will show GI or not? What will your answer?
No, sir.
No, sir.
Yes, sir.
No, sir.
No,
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 sir.
no, sir.
No, very good. No, very
No,
good. Because
sir.
this very good. Because this CH3 and CH3 are same, then the oxime will not form so GI. But if I will ask a question like this, PHCOCH3, this is called as acetophenone. So when this acetophenone reacts with hydroxylamine, then the oxime formed will show GI or not? What will your answer?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, because this pH and methyl are different. Because this ketone is unsymmetrical. Here pH, here CH3. When ketone is unsymmetrical, then compound will show GI. When aldehyde is unsymmetrical, then aldehyde will show GI. When reacts with hydroxylamine and forming oxime. Is it clear to everyone?
Yes,
Is it
sir.
clear to everyone?
Yes, sir.
Yes,
Yes,
sir.
sir.
If I will ask certain question related with that, can you solve that?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes,
okay.
sir.
Okay. Now think for this question. Think for this question. Question number 5. A5. Is it visible? Is
Yes,
it
sir.
Yes,
visible?
sir.
Now think for this. Question is asked, which of the following carbonyl compound will give two product after reaction with hydroxylamine? So think, this ketone is symmetrical or unsymmetrical? This ketone is symmetrical, unsymmetrical? Tell me. Here, think for this. Here CH2, CH2. Here CH.
Symmetrical.
Symmetrical.
Unsymmetrical. And when this is unsymmetrical, then the product formed, oxime formed, will be number 1 or 2. Number will be 1 or 2. What will you answer?
1.
No, when ketone is unsymmetrical, then product will be 2, because the product showing diastereomers. Product will show geometrical isomerism. Is it clear?
Yes, sir.
Here, think for this. CH3, CHO. Here CH3 and here H. This aldehyde is symmetrical, unsymmetrical?
Unsymmetrical.
Unsymmetrical.
Unsymmetrical. And if this unsymmetrical aldehyde reacts with hydroxylamine, then oxime formed will show GI or not?
Yes, sir.
Yes.
Yes, sir.
Then the number of oxime formed will be 1 or 2?
2.
2.
2.
Here
Two.
2 oxime will be formed. Here 2 oxime will be formed. But think for this third one. This ketone is symmetrical or unsymmetrical?
Symmetrical.
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 Symmetrical. When this ketone is symmetrical, then when this ketone is symmetrical, and this ketone when react with hydroxylamine, then the oxime formed will be in number 1 or 2?
1.
1.
One.
Very
One.
good.
One.
When symmetrical ketone react, it will only form one product. But when unsymmetrical aldehyde or unsymmetrical ketone reacts, it will form two products. Think for this. Hydrogen is replaced with deuterium. This is the isotope of hydrogen. This aldehyde, what you will say, symmetrical aldehyde or unsymmetrical aldehyde?
Unsymmetrical.
Unsymmetrical.
Unsymmetrical. Very good. Unsymmetrical. When this unsymmetrical aldehyde reacts with hydroxylamine, the number of product will be 1 or 2?
2.
2.
2.
Very good. Very good. What about this? This ketone is symmetrical, unsymmetrical?
Unsymmetrical.
Unsymmetrical.
Unsymmetrical. The number of oxygen formed will be 2 or 1?
2.
2.
2.
Very good. Because this part are different. Think for this aldehyde. Whether this aldehyde is symmetrical, unsymmetrical?
Symmetrical.
Unsymmetrical.
Think
Unsymmetrical.
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 Cyclopropyl groups. One side of COH, one side of CO cyclopropyl. This is unsymmetrical aldehyde. And when this unsymmetrical aldehyde reacts with hydroxylamine, the number of product will be 1 or 2. What do you answer?
2.
2.
2.
The question will be asked like this. Is the number of oxime formed? The number of oxime formed will be number in 1 or number 2. Can you solve such question?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now, question arises. You said that these two are different. You said that they are not the mirror image. Then how can you say that these are not the same? Because attachment are same. Here this carbon is attached with CH3H, nitrogen OH. This carbon is attached with CH3H, nitrogen OH. Similarly, if I will take like this, so here again CH3, CH, CH, CH3. Here again CH3, CH, CH, CH3. Then how can we say that this molecule and this molecule are different but both have same IUPAC name? So a configurational nomenclature was proposed. So as to differentiate this molecule and to differentiate this molecule. Similarly, to differentiate this molecule and to differentiate this molecule. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
The
Yes, sir.
next heading is nomenclature used in geometrical isomerism. Write it down. Write it down. Nomenclature used in geometrical isomerism. Write the heading. Nomenclature used in geometrical isomerism. There are three types of nomenclature, configurational nomenclature used in geometrical isomerism. First is called as cis-trans nomenclature. Have you heard it? Cis-trans?
Yes, sir.
Yes, sir.
In element class, you have seen this cis-trans nomenclature. But there are three types of nomenclature in geometrical isomerism. First is cis-trans, which is easy and simple. Second is syn-NT, and third is EZ. The first we will discuss cis-trans, followed by syn-NT, and later EZ. First cis-trans, right? Cis-trans nomenclature. Write the heading cis-trans nomenclature. Cis-trans nomenclature. Think for the cases, once again, think for the cases where geometrical isomerism arises. Think for the cases where geometrical isomerism arises. So these are the cases. These are the cases where geometrical isomerism arises. So nomenclature will be from this molecule, these molecule only. Now, cis-trans nomenclature is used for carbon-carbon double bond. Carbon-carbon double bond may be in open chain, may be of ring, and cycloalkanes. The cis-trans nomenclature is used in case of carbon-carbon double bond for open chain or ring along with cycloalkane. Is it clear? Is it clear?
Yes, sir.
Yes,
Good.
sir.
Good. Write it down. Write it down on your notebook. Right. Cis-trans nomenclature. Cis-trans nomenclature. Cis-trans nomenclature is used for carbon-carbon double bond and cycloalkanes. Cis-trans nomenclature is used for carbon-carbon double bond and cycloalkane. That will show GI. That will show GI. Those compounds, those carbon-carbon double bond or cycloalkane, that will show GI. In that case, cis-trans nomenclature is used. Look for this. If two same groups like this, here CH3, here CH3. Look for this also. Look for this also. Here CH3, here ethyl are different, but here H and here H are same. So if two same group may be CH3, you can also think for HH also. Here both same groups are on the same side of restricted bond. Here you can think for this H and you can think for this H. The condition is here A double bond B, here A, here B, here A, here B, it may be C. Here again, here A double bond B, here A, here B, here A, and here B or C. So when two same groups or atom are on the same side of restricted bond, then such compound are called as cis. But when same groups or atoms are on the opposite side of restricted bond, then such compounds are called as trans. Is it clear? Is it clear?
Yes.
Yes, sir.
When two same groups
Yes, sir.
or atoms are on the same side of restricted atom, then such compounds are called as cis configuration. While when two same groups are on the opposite side of restricted bond, then such configuration is called as trans. Is it clear?
Yes, sir.
Now, write in your notebook. When two same groups, when two same groups or atoms, when two same groups or atom are on same side of restricted bond, when two same group or atom are on the same side of restricted bond, then such configuration is called as cis, but when two same group or atom are on opposite side of restricted bond, then they are called as trans configuration. Is it clear?
Yes, sir.
Now, think for this. What you will say? This is cis or trans? This is cis or trans?
Cis.
Yes, very good. This is
Cis.
cis. What about this? Cis or trans?
Cis.
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 Everyone's clear? Now, think for this.
Yes,
Think
sir.
for this. If question will be asked like this. This is cis or trans?
Trans.
Trans. Because here one hydrogen is present. Because at this particular carbon, hydrogen is present. Over this particular carbon, hydrogen is present. And both hydrogens are on the opposite side of restricted bond. So it is called as trans. Is it clear?
Yes, sir.
This
Yes, sir.
these molecules are same. Look over this. CH3 double bond ethyl. CH3 double bond ethyl. CH3 carbon carbon double bond ethyl. Here again CH3 carbon carbon double bond ethyl. But in this case, two hydrogens are on the same side. So this is called as cis configuration. But here two hydrogens are on the opposite side. So it is called as trans configuration.
Trans.
Is it clear to everyone?
Yes, sir.
Yes, sir.
Now think for this also. It may be cis trans nomenclature can be used for cyclic system also. Think for this. If I will take like this 1,2-dimethyl cyclohexane. Both the methyl groups are above the plane. But think for this molecule. Here one methyl group is above the plane and one methyl group is below the plane. What you will say? This is cis or trans?
Cis.
Yes, because both methyl are in the same side. But what about this? Cis or trans?
Trans.
Trans.
Because both methyl groups are on the opposite side. Can you solve such question if asked in the examination? Can you solve?
Yes, sir.
Yes.
Now,
sir.
think for this. I'm taking a ring with 10 carbon. If I will place a double bond over this position, what you will say? This is cis or trans?
Cis.
Cis, because here hydrogen, both hydrogen are on the same side. And both hydrogen are on the same side, so this molecule is called as cis. But if I will place position of double bond over this position, bond, what about this? This is cis or trans?
Trans.
Trans. Here hydrogen here, alkyl groups opposite.
Trans.
This molecule is called as trans. Is it clear?
Yes, sir.
So this
Yes,
cis
sir.
nomenclature, So this cis trans nomenclature are used in 3 cases. First, in carbon-carbon double bond or open chain. Second, cycloalkane. And third, carbon-carbon double bond in the ring. Carbon-carbon double bond may be inside the ring. Carbon-carbon double bond may be outside ring. And cycloalkane. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now write the syn-anti nomenclature. Write the heading syn-anti nomenclature. Syn-anti nomenclature. Write the heading. Syn-anti nomenclature. This is SYN syn, not SIN syn. So never write SIN syn. What is that syn? SIN. You heard about that syn?
Sine cos.
That syn was different and this syn was different. SYN. This is syn. Now, syn-anti nomenclature is used for carbon double bond nitrogen system or nitrogen double bond nitrogen system. Okay, syn-anti nomenclature is used in these 2 cases along carbon double bond nitrogen and nitrogen double bond nitrogen. Is it clear?
Yes, sir.
Now write it down. Write it down. Syn-anti nomenclature. Syn-anti nomenclature. Syn-anti nomenclature is used for those geometrical isomers where carbon double bond nitrogen or nitrogen double bond nitrogen are present. Carbon double bond carbon, carbon double bond nitrogen or nitrogen double bond nitrogen. So syn-anti nomenclature is used for 2 cases. First for carbon double bond nitrogen and second for nitrogen double bond nitrogen. Now think, if it is nitrogen double bond nitrogen, it is very simple. If it is nitrogen double bond nitrogen, it is very simple. Here both groups are on the same side. Both lone pairs are on the same side. It may be both groups are same, it may be both groups are different. Here nitrogen double bond nitrogen. Here one group is here and another group is here. It may be same, it may be different. Here lone pair in this direction, here lone pair in this direction. So when both groups are on the same side of restricted bond, then such configuration is called as syn. But when both groups are on the opposite side of restricted atom, then such configuration is called as anti. Is it clear? Is it clear? Tell me.
Yes, sir.
When both groups, it may be same, it may be different. When both groups are on the same side of restricted bond, in case of nitrogen double bond nitrogen, it is called as syn. When both groups are on the opposite side of restricted bond along nitrogen double bond nitrogen, it is called as anti. It is called as anti. Think for this molecule. Think for this molecule. If I will write nitrogen bond and here H and H, what you will say? It is syn or anti?
Syn.
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 Called as syn. And if I will write nitrogen double bond nitrogen, here H, what you will say? Syn or anti?
Anti.
Anti. Here it is called as anti. Here it is called as syn. Is it clear to everyone?
Yes, sir.
Yes, sir.
Now for carbon double bond nitrogen. That's why I told you how carbon double bond nitrogen are formed. Now think first, formation of carbon double nitrogen once again. When aldehyde reacts with NH2Z, it will form compound like this. And when ketone reacts with
And
when ketone reacts with NH2Z, it will form compound like this. For a molecule to show geometrical isomerism, this end must have different substituent.
yes, sir.
So unsymmetrical aldehyde will show GI and unsymmetrical ketone will show GI. Now, think for this carbon double bond nitrogen obtained by the reaction of aldehyde. Think for this carbon double bond nitrogen obtained by reaction of aldehydes. Now, in case of aldehyde, two possibilities will be seen. Here H and this group are on the same side. This H and this group are on the same side. And second possibility is this H and group are on the opposite side. Isn't it? Tell me. This
Yes, sir.
H,
Yes, sir.
Yes, sir.
this group may be anything. This group may be anything. It may be H. It may be H. It may be R. It may be OH. It may be NH2. It may be this bigger part. It may be this bigger part. These all are considered as Z. G means group. These all are considered as Z. So one possibility is this H and G. One possibility is this H and G are on the same side. And another possibility is this H and G are on the opposite side. So when this H and when this G are on the same side, so it is called as syn. And when this H and the Z are on the opposite side, it is called as anti. Is it clear?
Okay.
It is clear?
Yes, sir.
Write
Yes, sir.
write this also. The carbon double bond nitrogen is H and G are on the same side, it is called as syn. And if this H and G are on the opposite side, it is called as anti. Write it down. Now think for ketones. Here, if this is R and this is R dash, this is R, this is R, this is R dash. So here R and Z are opposite. Here R dash and Z are on the same side. So when carbon double bond nitrogen is formed by reaction with ketone, when carbon double bond nitrogen is formed when reaction with ketone, so two possibility arises. Along with this R, in this R dash and G are on the same side, so it is called as R dash syn. This is called as R dash syn, or it may also be called along with this R anti. It is also called as R anti. When you're thinking along this R, it is called as R anti, and when you're thinking about this R dash, you will see R dash syn. Similarly, for this, you will see R syn. R and this group are on the same side, so you will see R syn. And this R dash and group are on the opposite side, so it will also be called as R dash anti. Is it clear?
Yes, sir.
Now I'm taking some example. To make your understanding better. Think for this. If I'm taking this pH, if I'm taking this CH3, and if I'm taking here OH. In second case, I'm taking here OH, I'm taking here CH3, and I'm taking here pH. So along with pH, when we taking this pH, what you will say? pH anti or syn? What you will say?
Anti.
And pH anti. So this compound is called as phenyl anti. But what about from methyl? This is called as methyl syn.
Sin.
It is clear? When we
Yes, sir.
when we are writing from the CH3, so it is called as methyl sin. And when we are taking this phenyl, so it is called as phenyl NT. Similarly, here this pH and OH are on the same side, so it is called as phenyl sin. It is called as phenyl sin. Whole phenyl groups are written, or in short form pH may be written. So phenyl sin, or in terms of methyl, it is also called as methyl NT. It is called as methyl NT. Is it clear to everyone?
Yes, sir.
Now write it down also. Write these also in your notebook. Write these also in your notebook. So when carbon double bond nitrogen is formed by reaction of aldehyde, here always be H. Here always be H. So we are not writing the H sin, H and D. We always think this H and G are on the same side, it is called as sin, and H and G are on the opposite side, it is called as anti. But in case of ketone, when carbon double bond nitrogen formed by reaction with ketone, in that case, both alkyl groups. So nomenclature arises from this alkyl also, and nomenclature arises along this alkyl also. Is it clear? Is it clear?
Yes, sir.
Now, if I will,
Sir.
very good. If I will take example like this, think for this. Here H, here pH. I am taking here OH. What you will say? Sin or anti? What you will say? Sin or anti?
Sin.
Sin.
Sin. Because this
Sin.
H and this OH are on the same side. When this H and OH are on the same side, it is called as sin. What about this? What about this? Here I am taking pH, here I am taking H, and here I am taking NH. NH, here taking CO, or again here taking NH2. What you will say? This is sin or anti? What you will say? Sin or anti?
Anti.
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 If one is hydrogen, so never think for this group. Never think for this group. H and this group, whole is a simple group. If this H and groups are on the opposite side, of this restricted bond, then this compound is considered as anti-configuration. Is it clear? No matter group is smaller, no matter group is larger. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Now think like this. Think for this molecule. If I'm taking this pH, if I'm taking this H, and if I'm taking like this, here NH, here I'm taking this phenyl, here I'm taking here nitro, again this position also have nitro. I'm taking compound like this. What you will say? This is sin or
Sin.
anti?
Sin.
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 Very
Sin.
good, very good. Because this H and this whole group are on the same side of carbon nitrogen double bond, are on the same side of restricted bond. So this particular is called as sin. Is it clear? Is
Yes,
it
sir.
clear?
Yes, sir.
Write these three examples in your notebook. Write these three examples in your notebook. Write it down. Have you done?
Yes, sir.
Take time. Because concept should be crystal clear. because stereochemistry is very much important in competitive examination. Now, think for this particular example. Is it visible? Is it visible?
Yes, sir.
Now, think for this molecule. What you will see? What you will see for this?
Anti.
Is syn or anti?
Anti.
Anti. Very good.
Anti.
Because here, hydrogen and groups. Never think for this CH3 and ethyl. Here, hydrogen and group are on the opposite side. Hydrogen and groups are on the opposite side. So it is called as anti. Never think that CH3 and ethyl are on the same side. Here hydrogen and this group are on the opposite side. So it is called as anti. Is it clear?
Yes, sir.
Now think for the second one.
Anti.
It is syn or
Anti.
Easy one.
Anti.
Because both groups are on the opposite side. When both groups are on the opposite side, it is called as anti. Now think for this third one. Syn or anti?
Anti.
Never think that this and this is methyl, both groups are on the same side. Never think that this OH and this groups are on the same side. Think that this hydrogen and this groups are on the opposite side. Think this hydrogen and these groups are on the opposite side. So it is called as anti. Is it clear?
Yes, sir.
Now think for this one. What about
Syn.
Thin.
Very good, beta. Very good. Because this H and this NH2. This H and this NH2 are on the same side. So it is called as syn. What do you say for this molecule?
Anti.
Very good. Because this H and this group are on the opposite side. So it will set as anti. Is it clear to everyone?
Yes, sir.
Is it clear?
Yes, sir.
Yes, sir.
Very good. The two nomenclatures you have learned today. One is cis trans nomenclature and another is syn anti nomenclature. In next class, we will study EZ nomenclature. Because in EZ nomenclature, some terms comes. First, CIP rule. Have you heard about this CIP rule? Have you heard about this CIP rule?
No, sir.
No.
No, sir.
That's why in next class I will first tell about CIP rule, and after giving information about the CIP rule, then only we will learn about this EZ nomenclature. Okay?
Okay, sir.
Okay, sir.
Now today's class you have learned about the formation of carbon double bond nitrogen, how carbon double bond nitrogen will be formed. And along with that, you have seen that two types of nomenclature. First is cis trans nomenclature and second is syn anti nomenclature. Isn't it?
Yes, sir.
Closing the class for today, and next class we will learn EZ nomenclature. Good night for today.
Thank you, sir.
Good night, sir.
Thank you, sir.